Three quiet lagoons sit along the coast of Delaware: Rehoboth Bay, Indian River Bay, Little Assawoman Bay. On maps, they appear completely separate from the Chesapeake Bay. Different waters, different tides, different drainage basins. But beneath the sand of the Delmarva Peninsula, scientists discovered a hidden water system. Rainfall sinks easily into the peninsula's porous soil. Instead of rushing into rivers, much of it disappears underground. That water enters a vast underground reservoir known as the Columbia Aquifer. This aquifer stretches beneath forests, farms, and wetlands across the entire peninsula. Water moving through this system travels slowly, sometimes taking years or even decades to reach the coast. Centuries ago, settlers noticed strange behavior in their wells. Some wells rose and fell with distant tides. Others became salty during droughts. The mystery deepened because the peninsula's watershed divide is almost invisible. In some places, only a few feet separate water flowing to the Chesapeake Bay from water flowing to the Atlantic Ocean. But underground, water does not always obey that divide. Long before modern coastlines formed, Ice Age rivers carved valleys across the peninsula. Today, those ancient river channels lie buried beneath layers of sediment. Scientists call them paleochannels, and they can guide groundwater flow beneath the land. Even deeper below the peninsula lies an even older force shaping this hidden water system. About 35 million years ago, a massive asteroid struck near the mouth of the Chesapeake Bay. The impact shattered underground rock layers and created a buried crater more than 50 miles wide. Those fractured sediments still influence how groundwater moves beneath the region today. In modern times, rainfall carries nutrients from farms and communities into the soil. Some of that water begins a slow underground journey, sometimes taking 10 to 40 years before reaching coastal waters. Scientists call this phenomenon legacy nutrients, pollution from decades ago that may only be reaching the Chesapeake Bay today. In some places, groundwater rises directly through the bottom of tidal creeks and bays. This hidden process is known as submarine groundwater discharge, fresh water quietly entering estuaries from beneath the sediment. Along parts of the coast, rising groundwater salinity has created eerie landscapes known as ghost forests. Trees killed by saltwater intrusion leave silent reminders of how groundwater conditions are changing. Even deeper underground, scientists have discovered fossil groundwater. Some of this water entered the ground thousands of years ago during the last ice age. In some places today, wells draw water that may have fallen as rain long before recorded history in the region. Only in recent decades have researchers been able to map these underground pathways using chemical tracers and isotope analysis. Their work revealed something remarkable. The peninsula's aquifers link wetlands, creeks, coastal bays, and Chesapeake tributaries in ways invisible from the surface. And the connection is personal. Many homes on the eastern shore and coastal Delaware rely on private wells drawing from this same groundwater system. The water beneath people's homes may eventually flow through marshes and creeks before reaching the Chesapeake Bay, meaning the region's rivers, wetlands, bays, and communities are connected by a hidden hydrological network. Not by visible rivers, but by water moving silently beneath the land. A reminder that the most important waterways are sometimes the ones we cannot see. If the water remembers it, we'll tell it. Subscribe to River Realm Life for more hidden stories from the Chesapeake watershed.